So this tutorial is how to make a gear, to attach to a motor, or like a stepper motor, or anything with a shaft. Especially if that shaft has a flat side, like a little locking flat side to it. What I mean by that is, if you look right here, let's see if I can zoom in here. So it's so when the shaft comes out of the motor, this is the motor sideways. If you look at it, one side is flat, so it's like round and flat, so it helps lock it from spinning. Otherwise, it's kind of hard to grab onto, you know. So how do you do that? So let's just create, and we'll call this gear on shaft. And we'll just call it that. And there's a gear is really hard to draw, and in this class, we're not here to try to learn how to draw the details of a gear. You know, there's probably like a whole entire mechanical engineering class that'll go over that. But for us, we can just do something really cool. So over here on the side is, if you go over here, it should look like that. So you'll see this like plus sign like this. It says add custom features. Just click it. I already added the gear thing for practice. So how would you do that? Click feature script examples, and there's a bunch of code in here. Then you can search for it, but it should be the first one. It was for me. Just type in spur gear. So just type in spur like that, and then here we go. There's spur gear, and it says feature script. So this is a code, and there's a bunch of code somebody writes to make it easier, so you don't have to do a lot for drawing. So just click that and install it. Okay. Once you do, you can kind of come over here and click it, and it'll open this thing, and it'll actually draw you a gear. And you can put how many teeth you want on it. Module, pitch, circle, diameter, pressure angles, root. So these are all parts of the gear. So like it's talking about the angles here and stuff like that. And it's all these little details about that. We're not going to worry about that. We'll keep it just as is. We'll just be like, hey, you know, that's good. Number of teeth is good because if we do like, 80, and then I do 80, you can see it turns into a much bigger wheel because it's got to fit 80, but it will fit into your other one, which will be smaller, which has only, let's say, 25 teeth on it, you know? So let's go 25 teeth, and let's keep it small for now. And that's about it. You can do a center bore. I guess you can put a hole on it if you want to, but we're not going to do that. So once you have that gear, there we go. We need to have a shaft on it. So first thing we're going to do is add a circle. Click on this face, and we're going to just add a circle because we need to create some extra material here to work with. So we're going to click here, and what is it, 0.63 inches? We'll just put 0.6 inches. We'll just do that for now. And you can extrude this, and if you need more later, you can. That seems like a lot. We'll just do 0.45 inches, which is a little more than a half an inch. That gives us a bunch of plastic and meat for the motor shaft to grab onto, and then we're pretty much done with that. Now let's start with the hole. You'll need to measure your hole. I have a whole lesson on this. If you go back to the yellow motor shaft video, there's a video on that. You can measure this big part with a dial caliper, and then measure the shorter part with the dial caliper as well. It looks like this is R and S. No, R and I don't know what the diameter of that is, but let's see. Where's R? So R, but they don't go, they go to R way down here. So this is wrong. That doesn't show what the R is on this one. So you'd have to measure your shaft then. So I'm just going to go ahead and pretend that I've measured it, and so we can get started here. So let's sketch this circle right here. So I'm sketching right here. And then I'm going to draw a circle. And this is the circle of the shaft of the motor, the main circle. And you're going to measure it. Of course, you'll write that measurement here. And let's say it's 1/8 of an inch, 0.125, but I don't know what it is. And then we do have a line, so I'm going to click the line, and we want to lock it totally flat, okay, like that. And honestly, it'd probably be better if you could, oh, so I accidentally clicked it right at the edge of the circle. Do you guys see that? That's not good. I do not want it there. So I'm going to go and delete it. Click it again. We want it kind of going through the circle, but we want it straight. So make sure it locks perpendicular. And if it doesn't, there's a tool for that right here, horizontal constraint. We can say, no, be perfectly horizontal. In fact, you can do that just to make sure that it is perfectly straight. Then go to the dimensioning tool and say, hey, how far is it from here to this edge of the circle? So you took your dial caliper, and on this flat edge of the metal shaft on the motor, you clicked here. I mean, you grabbed your dial caliper on here, and it's going to be smaller. It's going to be smaller than this number right here, you know? So definitely smaller. So let's say for me it's 0.1. I'm just making these up now. And then done. Now, let me go back and sketch this. You can totally clean it up. I don't think you have to, but if you want to clean it up, you can totally clean it up like this and delete all the extra stuff off. And then we're going to go ahead and cut that. By the way, if this is, we're not creating any tolerances here. So if you want to make sure there's room, round up a tiny, tiny bit, like maybe 3 or 4 thousandths of an inch, to give yourself extra room, because otherwise you're going to fight trying to get your motor to fit in here. You might have to like sand the inside of this and scratch it a little bit to try to fit it in. So it's up to you. I'm doing the exact dimensions here. So, oops. So we're going to go ahead and extrude it and just make a big hole all the way through. Say remove, and remove everything all the way through. I think I did, yeah. Good. So my shaft is going to go in here. And that's it. That should fit right there. I'm going to do another lesson on how to create screw. In fact, that doesn't actually look right. That looks like kind of small, because this is actually a really tiny thing. So I'm just going to do a quick sketch. And I'm going to go here and say that that's a 0.187. And I'm going to go here and say that it's 0.125. Probably a little bit more. 0.150. There we go. And then done. There we go. That looks more like it. So you would have measured these numbers, those two numbers anyway. How wide is the circle, and then how wide is it from the flat part? That's all you really need to do, and do it right in the center. And you have a really cool thing. This will fit perfectly. Could it slide off? Yes, it could. Is there some cool screw that goes through here and tightens? No. I'll have another video on that if you want to know. How would I make it so I can put a screw through and tighten it onto the shaft really good so I don't need to worry about it falling off? We'll do a video on that now.